Hello everyone. So today we are going to implement this frog simulation using Niagara effect system. So these frogs are created with mesh particles. So these are static meshes, and the animation is achieved through vertex animations. And yeah, let's see how to implement this Niagara particle today. Right, so I have imported this frog model. This is a static mesh, and I have also imported these textures, this base color texture and normals texture and EXR offsets texture. So these textures are created according to this tutorial. One of my friends helped me to help with the models. So using this method we can create animated static meshes. So let me just create a material for the frog first. Frog and frog. Right, here is the color, and let me set the frog mesh as the preview object. Okay, and also here let me add vertex animation tools mob targets. So here we have to put vertex normal into the normal and pixel shader vertex normal. We don't have to connect this one. World position offset into world position offset and UV index. Number of customized UVs we have here 3, so let me set this to 3. Now we got only UV1, UV2, so let me set this to 4. Okay, now we got 3 as well. Let me connect them. Right, now this looks like a mess. So let me import normals. Sorry, not the right frog. Normals and offsets here, and convert these to texture objects, because only then we can connect this. So this is offsets that should be connected to mob texture, and this is normals connected here. Right, now let me promote this to a parameter for now, mob animation. So if I leave it at 0, it's like this, and if I change that value, you see the fog's action changes, the stance changes. See, 0.2 here like this, 0.5 like this, 0.8 like this. So if I connect this to time, see, now you see a jumping frog, but I don't need that, so let me just leave it at 0 for now. I'm gonna come back here and no, wait, let me connect particle color to this. So because I can change the particle color from the Niagara system, so that by modifying the particle color values I can change the frogs animation frames. So that's what I'm planning to do. So right, that part is done here. And now one more thing, we have to disable tangent space normals, because I don't know if you remember, we ran into a problem in our rat model where we had some blackness near his foot. So to fix that, I have to disable that normal tangent space normal. So yeah, that's something not relevant to this episode, but someone had asked me in the comments in that rat simulation video, why is there a black patch near the leg? So that's near the foot, that's the reason. Okay, now let's go to our FX folder and create a Niagara system from selected emitters. So here I'll choose the sanguine particles and S prox. Wait. Oh. Okay. So now this is what we have. So let me remove the sprite renderer. We don't really need that. And add a mesh renderer. Right, now as the mesh, I'll set frog. Okay, first I forgot to set the texture and frog. Let me set that and save. Right, now we have the frog. Let me place it here. So this is not really the way we want it. So let me adjust it. No noises, we don't need any noises, and sprite size doesn't matter. Initial location, not a box, so this is okay, we need this. Lifetime, how about 10 to 15. Spawn rate, let me reduce to 10. Right, and here, so frogs are spawned in an area like this. So let me move it up a bit, and this box I'll reduce the Z so that they will be spawned in a very thin Z range like this, and this range, let me set a box of 200 wide, 200 long. Okay, that seems better. And also the frogs should fall into the flow. So let me add gravity force. But they're not really falling. Fix issue. Right. Now they do, but why are they falling through the floor? collision. Right, now they do stop on the floor, but some of them are still. Oh, why are they like this? Oh, here, drag. We don't need that. Oh, why are they bouncing up? And that's odd. Do we have any forces in action? Right, we don't need any initial forces. Oh, the gravity force should be here in the particle update section. Right, now that's correct, but they don't have to bounce. See, so under collision, under restitution, I'll set it to 0, and the friction to 1. Friction during a bounce also to 1. Right, now they are not bouncing. Okay, so let me set this to a value like this. Now none of the frogs are falling down. Great. Right, so the next challenge is making them jump. For that, let me add a linear force. And so this is the force. So we don't need all the frogs to jump in the same direction, so we need to have some variation here. And also, in order to make them jump, so it's not like adding a constant force for them to move as we did for the rats. So let me convert this to a multiply vector by float, and then in order to have a change its direction, I'll change this to make vector x for x1 fine, z also 1 fine, y. Let's change this. Let's change this to a sign. Period 1, scale 1, bias 0. Let's set the period to 3. And instead of the emitter edge, let's use edge of the particle. Right, now still they are not moving because they don't have a significant force. But if I may increase this, they will start moving. See, but this is like a walking movement, a constant movement. That's not the way I need them to move. They should be jumping. So let's convert this float. Let's add another multiplier here. First multiplier, let's keep a value. Let's start with 5000 and set a value, but they are like flying over now. So this is because the force is constantly applying, but we only need to apply like in pulses, like in every 3 seconds or in every 4 seconds, something like that. So for that, I'm going to first let me add a clamp, because I'm going to use a sine wave here, and if I don't have a clamp, I will also have negative values as well. And here a sine value, for a sine, from a sine curve we get value in between -1 and +1. So here let me add a subtraction 0.95 so that any value larger than 0.9 value will have a 95 will have an effect. This part I'll convert to a sine. Okay, here also I'll use edge of the particle period. I don't know, we can change that. Now let's see, do we see any effect? It's very small, see, they are actually jumping but very small. So if I change this, where's the multiplier? Let's try 40,000. See, now they are jumping, which is good, but still not enough. It actually looks kind of good already. So one problem is the frog is always facing the same direction. They are not changing their direction. For that we can change this facing mode to velocity. Wait, now they keep pointing upward. That's not the way we need it. Yeah, actually if we have a very small force, a constant force, we may be able to avoid that. So let me again add a linear force, and I'll use the same vector math I used here. Copy and paste. Wait, multiply the float and paste. Okay, now the frogs are facing, oh wait, they are facing up. No, they should be horizontal, so I have to remove this Z. So yeah, now they are facing forward but they are rotating as well. Therefore we can reduce this total value. Oh, but they are still rotating. What if I change this period to like 20? Oh, well, that period is 20 and this 20 has to match, otherwise it doesn't look, frog shows some sudden rotations. Okay, now it seems fine. Right, now to get the animation, but before that I think we should make them jump a little high. So how about if I make these two? Oh, too much. Oh, is it? Maybe not. It's fine. maybe a little further too. So 50,000. Okay, and I feel like, oh, one more shit, like they are moving too much into that direction. So actually that's because where's the lifetime? Here the lifetime is 10 to 15, but the period is 20 seconds. So that's the issue here. So if I make this 10 in both cases, it should be fine. Yeah, now they are jumping in all the directions. Great. So the next thing is getting the animation. Yeah, so for that I have already set this particle color. So let's add by color, scale color by speed. Let me add this node, and here now let's see now we already get some jump in animation, but it doesn't look right. What if I limit this to something like 700 and min threshold to 0? Ah, great. Now everything seems fine. See? And another thing would be, maybe we can do some randomization to the scale. It's random uniform, yeah. Maybe not that difference. That should be a good ratio. Okay. Alright. So if I change the spawn rate to 20, let's see. I have to compile. Great. Now here are our frogs. And they are not really smart. They can't actually avoid the player and go away. But maybe that is something we should advise in another episode. But yeah, here is the final demonstration. And I'm going to stop this episode right here. So I added some specular, metallic and roughness parameters also with these values to the material, and this is the final look. Here is our frogs simulation with Niagara. And thanks for watching. As always, project files will be available for the download in the Patreon page. Link would be in the description below. And if you like to support my work, you can get the membership of the Patreon club. See you in another episode. Goodbye.